The James Webb Space Telescope recently made a discovery that amazed scientists and sparked curiosity about the possibility of life on other planets. While observing Proxima Centauri b, the closest star to Earth, the telescope detected unusual bright lights that looked similar to city lights. This raised the question of what could be causing these lights on a distant planet. Could it be a sign of life beyond Earth? For years, people have wondered if life exists elsewhere in the universe. Scientists have been searching for proof, and the idea of discovering life outside Earth has always been fascinating. Until now, the thought of finding such evidence felt like science fiction, but this discovery has brought it closer to reality. The possibility of other life forms is exciting, and any evidence supporting this idea is welcomed with great interest. What makes this discovery even more remarkable is how unexpected it was. The scientists working with the James Webb Telescope did not plan to find city-like lights in space, especially from a planet so far away. This discovery is significant because it might be one of the first real pieces of evidence that life exists elsewhere. For years, researchers have hoped for something like this, and now it seems we might be closer than ever to understanding whether life exists beyond Earth. If these lights come from an intelligent civilization, it could mean that alien societies are very different from anything we can imagine. It is amazing to think that these lights may have existed for a long time, waiting for us to develop the technology to detect them. Proxima Centauri b is a unique planet that behaves differently from others. Most rocky planets absorb sunlight and release heat as infrared energy, but this planet does not follow the same pattern. The James Webb Telescope, designed to study infrared light, has been crucial in investigating Proxima b. It detected an unusual heat signature which may reveal important details about the planet's atmosphere. This is particularly important because Proxima b is located in its star's habitable zone, meaning it might have conditions that allow liquid water to exist. Water is a key ingredient for life, so scientists are eager to discover if Proxima b could support life. By using infrared imaging, researchers hope to learn more about the planet's atmosphere and whether it has conditions suitable for humans or other life forms. The telescope can also detect faint lights in space, making it an ideal tool for investigating the city-like lights reported on Proxima b. These lights could provide valuable information about the planet's surface, especially during its night cycles. Proxima Centauri b has interesting conditions because it orbits its star, experiencing day and night cycles like Earth. Without an atmosphere, the planet would have extreme temperature differences. The day side would be scorching hot, while the night side would be freezing cold. However, if it has an atmosphere, it might regulate the temperatures, creating more stable and livable conditions. Scientists are studying Proxima B's 11.2-day orbit to track temperature changes. By observing these patterns, they can determine if the planet has an atmosphere and what its characteristics might be. They also plan to analyze the atmosphere's chemical composition, searching for gases like oxygen, methane, and water vapor, which are essential for supporting life. This discovery is a major step forward in the search for life beyond Earth, and the data collected from Proxima b could bring us closer to answering one of humanity's biggest questions: are we alone in the universe?
Future telescopes will improve our ability to filter out the light from stars, giving us a clearer view of the faint light reflecting off distant planets. This advancement will make it easier to study the atmospheres of these planets and search for signs of habitability. By reducing the interference from stars, scientists can dive deeper into exploring whether these distant worlds could support life. This progress could help answer one of science's biggest questions: are we alone in the universe? However, many challenges remain. One major issue is distinguishing between gases produced by living organisms and those created by natural processes like volcanic activity. For instance, volcanoes can release gases such as carbon dioxide and methane, which might not necessarily indicate the presence of life. Scientists need to develop methods to differentiate between biological and non-biological sources of these gases. As research continues, the question of life beyond Earth becomes increasingly urgent. Humanity has been searching for life beyond Earth for decades, using advanced technology to seek answers. Despite the lack of concrete evidence, the search continues with tools like the James Webb Space Telescope, which help scientists study distant planets and their potential to host life. The idea of alien life has captured human imagination for centuries, and many hope that one day we will find definitive proof that we are not alone. The SETI Institute, founded in 1984 by Jill Tarter and Thomas Pearson, plays a key role in this search. SETI focuses on finding signs of extraterrestrial intelligence, particularly through radio signals that could indicate communication from alien civilizations. Radio waves are ideal for long-distance communication because they travel vast distances without degrading. Despite decades of effort, no conclusive signals have been found. However, Jill Tarter remains hopeful, believing that advancements in technology and global collaboration could accelerate the search for alien life. The James Webb Space Telescope is pivotal in uncovering the secrets of the universe. Its sophisticated instruments can analyze light to determine the chemical and physical properties of distant objects. This technology is helping scientists search for signs of life on exoplanets and uncover mysteries about the early universe, including the surprising amount of hidden mass in massive galaxies. 20 years ago, we knew very little about the universe beyond our solar system. Today, astronomers have discovered over 4,000 exoplanets, revealing incredible progress in our exploration of the cosmos. NASA estimates there are trillions of exoplanets yet to be discovered, and the search continues for signs of alien life. Past missions, such as Galileo's visit to Jupiter, have shown promising biosignatures like the vegetation red edge, suggesting the potential for life beyond Earth. The James Webb Space Telescope offers new possibilities for exploring the atmospheres of exoplanets, especially those in the habitable zones where conditions might support life. By analyzing light passing through these atmospheres, scientists can learn about their composition and determine whether they could sustain life. Researchers are even looking for artificial chemicals, like chlorofluorocarbons, which might indicate advanced civilizations using industrial processes. The search for life isn't limited to Earth-like conditions. Extremophiles, organisms that survive in extreme environments on Earth, demonstrate how adaptable life can be. These organisms thrive in extreme heat, acidity, and other harsh conditions, showing that life might exist in environments we previously considered uninhabitable. Red dwarf stars, which are smaller and cooler than our Sun, are also gaining attention. Their long lifespans make them promising hosts for planets where life could evolve. One fascinating system is TRAPPIST-1, which contains 7 Earth-sized planets, 3 of which are in the habitable zone. These planets could potentially host liquid water, making them exciting targets for further study. The TRAPPIST-1 system, located 41 light-years away in the constellation Leo, has opened new doors in the search for life. The system's planets are being studied closely to determine their potential for habitability. Similarly, Proxima Centauri, the closest star to Earth after the Sun, has a planet called Proxima B in its habitable zone. This planet, while facing harsh conditions, has raised interest due to its potential to host liquid water. Proxima B is tidally locked, meaning one side is always facing its star while the other remains in darkness. This creates extreme temperature variations, but the planet still receives enough sunlight to keep its surface temperature similar to Earth's. However, its proximity to Proxima Centauri subjects it to intense radiation, which could strip away its atmosphere if it lacks a strong magnetic field. Despite these challenges, scientists remain intrigued by the possibility of life on Proxima B, especially in forms adapted to harsh conditions, like extremophiles. If life exists there, it may look very different from life on Earth. Understanding more about Proxima B's atmosphere, volcanic activity, and magnetic field could provide crucial insights into its habitability. The discovery of seas or water on Proxima B would make it an even more promising candidate for life, intensifying the search for advanced civilizations. Some speculate that advanced beings might have adapted to the planet's conditions, possibly using technology like massive solar panels to harness energy. As research continues, scientists are eager to gather more data about Proxima B and other exoplanets. The possibility of observing Proxima B passing in front of its star could provide critical information about its size, mass, and density. Each discovery brings us closer to understanding the potential for life beyond Earth.